Okay, after doing those three cases, we have two special cases in the integration by rational fraction. Let's start with the first case. Now, till now we were doing numerator is greater, numerator is equal to, numerator is less than. Those were the three cases. Now, what if there is no numerator? If you get a question as dx divided by x minus 1 whole square, x minus 2, what will you do in these kind of sums? In these kind of sums, because you do not have any x on top, so how will you compare the numerator and denominator? In these kinds of sum, what you do is that let this expression 1 divided by, this is what, 1 divided by x minus 1 whole square x minus 2 equals to, how many expressions are over here? If you see it, x minus 1, x minus 1, x minus 2. So what we write these expressions as, a divided by x minus 1 plus b divided by x minus 1 whole square we write, because this is square. So had it been over here x minus 1 cube, so it would have been a divided by x minus 1 plus b divided by x minus 1 whole square plus c divided by x minus 1 whole cube plus d divided by x minus 2. Understood? So the number of times this is written, that number of expression we will be taking. Since x minus 1 whole square it is, so a and b we take x minus 1 whole square. Remember, this will be square, plus c divided by x minus 2. Now again multiplying both sides with x minus 1. After knowing this thing, it is the same for all the cases. Multiplying both sides with x minus 1 whole square, x minus 2. So if we multiply this one, you get left hand side you get 1 equals to a into x minus 1 is already there. So if you multiply with x minus 1 whole square, x minus 2, so x minus 1 x minus 1 x minus 1 gets cancelled, so 1 x minus 1 is already left in the expression. So x minus 1 x minus 2 plus b x minus 2, because x minus 1 whole square and x minus 1 whole square cancels, plus c into x minus 1 whole square. So this is your expression. Again our goal is to make either two expression 0 and find the third one. So what I am doing is that putting x equals to 1. Now when I put x equals to 1, this expression becomes 0. Again this expression becomes 0. So I get the value of b. So x equals to 1, b equals to minus 1. Now again if I put x equals to 2, so 2 minus 2 is 0, 2 minus 2 is 0, I get the value of c. Now see over here, I got the value of b as minus 1, I got the value of c as 1. How do I find the value of a? Because whatever I put over here, I will not get the value of a straight away directly. Now what I try to do is that I put x equals to 0. If I am putting x equals to 0, then you see 1 equals to a is what? X minus 1, 0 minus 1 is minus 1, x minus 2 is minus 2, b is 0 minus 2 is minus 2, c is 0 minus 1 whole square is 1. So 1 equals to minus 2 into minus 1 plus 2, a minus 2b plus c. So I am getting 2a plus 2a minus 2b plus c, 1 equals to 1. Now what I am trying to do is that I am putting the value of b and c in this expression. So if when I put the value of b as minus 1, c as 1, so 2a minus 2 into minus 1 plus 1 into 1. So that is my expression. From there I move to 1 equals to 2a plus 2 plus 1. So I get this. So from there ultimately I get a equals to minus 1. So I get a, b and c. A is minus 1, b is minus 1, c is 1. Now same thing, I put, this was my original question. So over here I put integration and try to solve. When I put and this and try to solve, it is a is minus 1, so minus dx by x minus 1. B is b dx by x minus, so b is my again minus 1, so I put minus into integration of dx by x minus 1 whole square, and c is 1, so dx by x minus 2. So this is minus log x minus 1 minus x minus 1 to the power minus 2 dx plus log x minus 2. So minus log x minus 1 minus this is x minus 1 to the power minus 1 divided by minus 1 plus log x minus 2 plus c. So minus log x minus 1 plus 1 by x minus 1 plus log x minus 2 plus c. So this is my ultimately my answer. So you see the special case, first one is that when you get dx by this one, this square or 3 or 4 or whatever you get, you have to solve that number of expression. A divided by x minus 1 plus b divided by x minus 1 whole square, always remember, and then it is the ultimately how we are trying to solve. Here we will get b, we will get c, or we will get any two expression. Third one you can get by putting x equals to 0 and then ultimately solve. This is your first case. We move to the second case. In the second case, what the question is, x cube dx divided by x4 minus 2x square minus 8. Now in the second case, what happens is that if numerator contains only odd power of x and denominator contains only even power of x, numerator is only odd, denominator even, then we follow, this is the second case, number B, special second case. So we take x, let x square equals to u, so 2x dx equals to du, so x dx is du by 2. So if we take this expression x cube, we break x into x square du divided by x square whole square minus 2x square minus 8. We get this. Now let this, put this in the expression of u. So x dx, I take it together, x dx is du by 2, so I am putting du by 2. X square I am putting as u, so u du divided by x square is u square minus 2u minus 8. So when we do middle term factorization, we get half u du divided by u square minus 4u plus 2u minus 8. We do middle term factorization, ultimately you will get u du divided by u plus 2 and u minus 2. Now you see this expression, we are getting the first case, numerator is 1, denominator is u square. So we go for the first case and solve it that way. So how will we do? I'm doing this one for you. So u by u plus 2, u minus 4, a divided by this, again multiplying u plus 2, u minus 4, you will get ultimately u equals to a, this one, putting u equals to plus 4 and u equals to minus 2, you ultimately get a equals to 1 by 3, b equals to 2 by 3. So this whole expression we put as, we got the question as this one, the whole question we got as half u du, this whole expression. So I write half into a by u plus 2 du plus b by this one. So a's value is 1 by 3, so 1 by 3 log u plus 2, so 1 by 3 log u plus 2 plus 2 by 3 the value of b log u minus 4. So you get 1 by 6 log x, instead of u I am writing x square plus 2 plus 1 by 3, because this 2 cancels, 1 by 3 log x square minus 4 plus c. So this is your last special case. So we have 3 normal cases, 2 special cases. 3 normal cases is what? Numerator less than denominator, numerator equal to denominator, numerator greater than denominator. Special case number 1 was when there is no numerator, that is when we are given dx divided by some expression. And special case number 2 is that if numerator contains only odd power of x and denominator only the even power of x, so we can solve it by this way. Now there are few questions which I am giving you to solve along with the answers. Please take note of those questions and answers and try to solve, and do let me know if you are having any difficulty in any kind of questions. Do revert back with me to me if for any kind of doubts, because we've completed with integration by rational fraction. Next class we will start with the definite integrals, and I'll be soon coming up with one more video. So until and unless, because I will be keeping on providing you with the videos, but if it is of no use to you, if you're not understanding it, let me know, because I will have to find some other way or other means of teaching. And if it is good and you're quite comfortable with this, then we can continue with these kind of series and videos. Just see the questions and do pause and make note of the answers of all the questions which I gave you. I've given the answers to over here. Thank you. We've completed with integration by rational fraction. Any kind of doubts and queries are welcomed.